One of the things we've been working on recently is the law of cosines, and we had a poll asking which problem students would like to see on video, and we already did number 17, and the second place vote getter was number 15. So that's what I'm going to work on today. We are asked to solve each triangle, and so that means we're basically looking for the three angles because I already have the three sides. So I'm looking for the measure of angle A, the measure of angle B, and the measure of angle C. Then we're going to find those three angles. And as you know, we're going to use the law of cosines to do that. So let's start by, we'll get angle A first because it's first in the alphabet. So that's going to be, we want to use the formula A squared equals B squared plus C squared minus 2BC cosine A. That's the formula we're going to use, the version of the law of cosines that we're going to use. For us, that means 11.4 squared equals 13.7 squared plus 12.2 squared minus 2 times 13.7 times 12.2 times the cosine of A. And we're trying to solve for angle A. So I'm going to do a little bit of calculating on my calculator here. I'll do the 11.4 squared. I'm going to subtract the sum of 13.7 squared plus 12.2 squared. And when I do that, I get negative 206. Oops, I wanted to do that in yellow. Sorry about that. I get negative 206.57. And that's going to equal negative 2 times 13.7 times 12.2, which is negative 334.3 cosine A. And then to solve for A, I'm going to divide by negative 334 and then do the inverse cosine. So the measure of angle A is going to be the inverse cosine of negative 206.57 divided by negative 334.3. And when I compute that, I get approximately 51.8 degrees. So for letter A, I'm going to put in 51.8 right here. I'm going to have to do the law of cosines again to get angle B. I suppose I could do law of sines as well, but I'll do the law of cosines because we're practicing that. And then we'll use subtraction to get angle C. So for angle B, let's see if I can fit this right on the slide because I want this to be completely messy apparently. I'm going to draw a little line here to separate that. And then for angle B, we'll use the formula B squared equals C squared plus A squared, or A squared plus C squared, minus 2AC cosine B. And when we put the information in, we'll get 13.7 squared equals 12.2 squared plus 11.4 squared minus 2 times 11.4 times 12.2 cosine B. And again, I'm going to do some calculations here. I will do 13.7 squared minus the sum of 12.2 squared plus 11.4 squared. And when I do that, I get, that's going to be negative 91.1. And I also computed 2 times 11.4 times 12.2, and that is negative 278.2 cosine B. So we know that angle B is going to be the inverse cosine of that division, negative 91.1 divided by negative 278.2. And when I compute that, I get approximately 70.9 degrees. So I'll put that in for angle B. And then to get angle C, we're just going to use subtraction. So again, I'll just draw a little spot here. And so angle C is just going to be 180 minus 70.9 minus 51.8. And that equals 57.3 degrees. And so I'll just add this up to my little answer list here. What did we say it was? 57.3. Come on, man. 57.3 degrees. Okay, so to solve this triangle, we had 11.4, 13.7, and 12.2 for the sides. And using the law of cosines and a little bit of subtraction, we figured out that the angles are 51.8, 70.9, and 57.3 degrees. So that'll do it for number 15. I'll see you soon.